All right, class, so this is an ALEKS topic that's called Distinguishing Solid, Liquid, and Gas Phases of a Pure Substance. This particular problem, we've got these diagrams with these sliders to select different diagrams. Obviously, we can't do that here, but I've printed out examples of all of the pictures to show you. So when you're doing a problem like this, the first thing you want to orient yourself to is what actual compound you're talking about. In this case, we're talking about carbon monoxide, so just one carbon and one oxygen. I've just drawn a little picture here. What we're trying to illustrate here essentially is that we're going to have a carbon atom. That's going to be the black dot, really. That's going to be bonded to an oxygen atom, so that's going to be the red dot. So this CO molecule is going to be two atoms bonded together. So in our pictures, we're going to be looking for something that looks like that, essentially. So we're also given the melting points and the boiling points. So the melting point, that's going to be where it changes from solid to liquid, right? So below that temperature, below minus 205 degrees Celsius, we're going to have solid CO. In between these two temperatures, we're going to have liquid CO, and then above this temperature of minus 192 degrees Celsius, which is a really low temperature, above that temperature, we're going to have gaseous CO. So down here, it says what temperatures we're sort of looking at for each one of these scenarios. So minus 177 degrees Celsius, although that is a very low temperature, it's above the boiling point of CO. So in A, we should actually be looking for a picture that is gaseous CO. That would be in the gas phase. B, minus 209 degrees Celsius, well, I would expect a solid under these conditions, right? It's below the melting point, so it should be a solid, it should be frozen. And then this minus 197 degrees Celsius, that's in between the two temperatures, and as you might expect, that should be a liquid. So that is what we're looking for in our pictures. So let's look at a bunch of the different pictures. So let's put this here, and then move these into place. I guess we're gonna have to squeeze in here. So let's look at, we'll just do one row at a time, basically. So here's some of the options that you might get for our different pictures. Now, immediately, I'm going to rule out a few of these. A few of these we're never going to use because they don't represent CO properly. This picture here, for instance, I've got oxygen atoms lone by themselves. I've got carbon atoms lone by themselves. They're sort of moving around. This looks like it might be a liquidy mixture of carbon and oxygen atoms, but I'm not seeing distinct CO bonded together molecular structures. So this picture over here really represents a carbon, oxygen, carbon, oxygen, carbon, oxygen. This would represent more of a solid, but we'll get to that in just a minute. But this does not even represent CO at all. Same with this one, right? This does not represent CO at all because I've got distinct atoms. They're not bonded together. And over here, I've got oxygen atoms, oxygen diatomic molecules, so these would represent oxygen O2, and then just single carbon atoms. So I can just go ahead and take these ones out completely. These will not be correct answers ever because they don't even represent CO. So let's bring some more examples in. Squeeze these in. I've got two more. We'll get to those as well. So in these examples here, this one again, I can take this one out. I've got carbon and oxygen separated. I don't have a CO, so that one's never going to be the option. Never going to be a good option. These are actually exactly the same, so I can get rid of one of those. So now we've got a few more to go through. This is what CO looks like. We've got carbon bonded to oxygen. This one we can take this one out. We've got single atoms, so not CO. And same with this one. So in this case, I've got again carbon and oxygen, O2 bonded together. So these are really my three different options. So for all of these, what I'm really going to be looking for is something that looks like one of these. So this would represent the gas phase. So they're further apart from one another. This represents the liquid phase. They're moving around. They don't have very good ordered structure, but there are definitely CO molecules moving around. And this would represent the solid phase, right? So they're aligned in a crystal structure. There's good order. So this is going to be the solid picture that we're looking for. This is going to be the gas picture that we're looking for, and this is going to be the liquid picture that we're looking for. So that's how I would line those up. Now, some of these other ones, like this one for instance, this does show a gas, right? This looks like a gas, but it's not a gas of CO. That's why this one is going to be ruled out. Same with this one. This would be a liquid. This looks more like a liquid to me. But again, I've got O2 and single carbon atoms, so it's not CO. So we have to make sure that we're paying attention to what the actual, chemical molecular compound that we're actually talking about for this problem. All right, hope that helps.